Good day. This is Neil Mitchell, and I'm going to talk to you about solving rational equations 5.5. So, what rational equations are is really it's problems that involve fractions, but the x is probably in the denominator rather than the numerator. So let's start off with the first example. This is on page 326 if you have a book. Example 1. And let's write out this problem. 2/3 minus 5/6 equals, now if this was equal to x, it wouldn't be too hard to solve, but this is 1 over x. So that makes it a little bit more difficult, but not impossible. I'm going to introduce you to, I'm going to try to show you the fastest way to do these. So we're going to use something called the magic number. Not a very good math term, but it makes it kind of easy to work the problem. What we're going to try to do, the whole object of this, is we're going to try to cancel out all these denominators and write an equivalent equation that doesn't have x in the denominator, just has a single equation without any fractions. So to do that, what I'm going to do is I'm going to multiply all these numbers together, 3 times 6 times x. If it's fairly small like this, 18x, I can use that. I can also use 6x because all these factors would go into that. But, to make it easy for ourselves, let's just times all these together, 3 times 6 times x. And let's write this over each term, 18x, 18x, 18x. And what we're going to try to do is we're going to try to divide the 3 into the 18 and then reduce this problem, okay? To cancel off this 3. So I'm going to cancel off this 3 by dividing the 3 into the 18, which would give me 6. So now I have 6x times 2, which is 12x. Okay? So I'm multiplying all these together, 6 times x times 2. Don't forget to write down the x, though. 6 divides into 18 3 times. 3 times x times 5, 15x. X cancels out the x, so I just have 18 times 1 is 18, no x. So now see, I've got a nice equation here. The value of x in this equation is the same as the value of x in the original, but I don't have to deal with fractions as much. So now this is going to be 12 minus 15 is a negative 3x equals 18. I'm going to divide both sides by negative 3. And x is simply negative 6. And now I have found the answer to this problem. So this is the idea of using what we call the magic number. We multiply all these together. And you got it made. Bing, bada bing, bada bing. Okay, let's try another one. More complicated looking. X plus 1 over 2. This is example 2. X minus, this is minus x minus 3 over 3 equals 3. Here we have some x's, and they're not in the denominator, but it is kind of complicated. So once again, first of all, we're not messing around with the numerator too much, but I do want to put these in parentheses. If you have like a binomial or some kind of term like that, you want to put it in parentheses. This one, not necessary. It was just a single monomial term. But if you have binomials, trinomials, put them in parentheses. Okay, also let's put this 3 over 1 to create a fraction. So common denominator, magic number. So the magic number, 2 times 3 times 1, easy enough to get, 6. Going to put a 6 over each one. Divide, 2 into 6 is 3. 3 times this whole thing, 3 times x plus 1. Operation minus, 3 into 6 is 2. 2 times x minus 3. Equals, 1 into 6 is 6. 6 times 3 is 18. So I've eliminated all the denominators. That's the whole idea. You don't want any denominators. Divide, divide, divide. Multiply, multiply, multiply. Okay, now distribute 3x plus 3 and solve it like you normally would do. Distribute the negative 2 and be careful here. This is going to become a positive 6, right? Sign change equals 18. Combine the like terms. X plus 9 equals 18. Finally solve it. Subtract 9 from both sides. X is 9. Now we want to make sure 9 works. You know, we can't have any zeros. So this looks pretty good. And our answer is 9. All these x's in this problem are equal to 9. All right, let's try another one here. I'm not doing the checks on them, but I probably will on this one. Okay, this one looks really complicated. Example 3. 2x over x minus 3 minus 6 over x equals 18 over x squared minus 3x. So this one obviously is more complicated than the problems we've been working on. So what we're going to do is we're going to, first of all, take this very complicated term here and factor it out. So we have 2x over x minus 3 minus 6 over x equals 18 over, we're going to factor out an x, right? X minus 3. So I'm going to look for my magic number. The magic number is something that will cancel out an x minus 3 and an x. Okay, so my magic number is just going to be those two things, x and x minus 3. That will also take care of this term also. This is actually what we're going to use, x and x minus 3. So let's write that down. I'm going to do that in ink here. X minus 3. X minus 3. Almost out of ink here. X minus 3. So the object is, I'm writing this over each term so that certain things are going to cancel. Like here, I'm going to cancel out the x minus 3 with the x minus 3. What is that going to leave me? It's going to leave me with x times 2x, which is 2x squared, minus. Here, the x is going to cancel out the x. See, I want to get rid of these denominators, and that leaves me with 6 times x minus 3, because they're factored out. See, these are already factored, so I can cancel. And here, I'm going to cancel out the x with the x, and the x minus 3 cancels out the x minus 3 on the top and the bottom, so I end up with just 18. This is the crucial step because we want this to have nothing but numbers, no fractions. Okay, now I'm going to distribute this out. 2x squared minus 6x, sign change, plus 18 equals 18. This is a quadratic equation, so it has to be set equal to 0. Going to bring the 18 over to get it to equal 0. And the 18's cancel, so I ended up with 2x squared minus 6x. Now to solve this problem, I'm going to have to factor that out. I'm going to take, and I'm not going to use, binomial factoring. I'm just going to take out a 2x. 2x times, this would give me x, right? 2x times x minus 2x times what? 3 equals 0. Then I'm going to solve like I had before. I'm going to take each part, set it equal to 0, and solve. If 2x equals 0, well, to get a 0, one of these, the x would have to be 0. 0 times 2 is 0. So x has to be 0. X minus 3 equals 0. Here we have a negative, so let's bring it over to the other side. Add 3, x is 3. Now, one thing I have to do, I have a pretty good answer here, but I have to make sure when I'm dividing, remember, you can never divide a number by 0. Number divided by 0, no can do. So we can see if I have this 6 and I divide it by 0, that's not going to work. That's going to give me, that's not possible. So this, even though I got a nice answer, this answer does not check. Okay, it's invalid. Invalid. Boy, that pen is almost dead. Okay, now the next one, I'm going to do the same thing. I'm looking for another pen here. I think I got one. Okay, so on this one, I'm going to put a 3 in here. But what happens when I put in a 3? I've got x minus 3 right here, the original problem. I had something like 2x over it. So if I put a 3 in here, I've got 6 over 3 minus 3 is 0. Number over 0, no can do. If I substitute the 3 in here, you see I've got 3 minus 3, and that gives me 0. So this is not going to check either. So in this case, we got two answers, but neither one checks. There is no solution. No solution. Kind of a crazy problem. Most of the time, you usually get one solution, but maybe one of the numbers doesn't work. But you have to check them to make sure. I'm not going to count the problem totally wrong because I know you worked hard to get these answers. But if they don't check, I can't give you full credit. All right, bing, bada, bang. All right, let's try another one. Here we go. On this problem, we have 2 over x minus 1 equals 3 over x plus 1. Kind of a mistake on this one is students kind of want to use like a negative 1 or something up here. You have to use the whole thingamajig, okay? So we need both of these things. We need an x minus 1 and an x plus 1 on each term. I like to do it this way because then I can kind of see. I see here the x minus 1's cancel, and I get 2 times the quantity x plus 1 equals. Here I see the x minus plus 1's cancel, so I have 3 times x minus 1. I'm going to distribute that out. Okay, well, I see there's no quadratic terms, so it should be pretty easy to solve. I'm going to bring the 2x over here because that way I'm dealing with a positive number. So I'm going to cross this off, bring it across the sign. Now it's negative 2x. Same thing with minus 3. I'm going to bring it over to the other side. Let's bring this 3 over here, positive 3. 5 equals x. Okay, let's check it. 5 minus 1, 4. That's fine. 5 plus 1, 6. Perfect. This is my answer. Works. Okay. So sometimes, sometimes they don't work, sometimes they do. Okay, here's another one. Okay. I have 2 over x plus 5 plus 1 over x minus 5 equals 16 over x squared minus 25. Okay, first step I want to do is I want to factor this out. See what I got here. Okay, x plus 5, x minus 5. You recognize this pattern? Difference of squares, perfect square minus x, 5, 5 times 5 is 25, plus and minus. Same factors we had. So in order to cancel out the x plus 5, I need an x plus 5 on each term. Cancel out the x minus 5 on each term. So I'm going to write that down. Let's see if I got a better Got a red pen here. Maybe we can use that. X plus 5, x minus 5. X plus 5, x minus 5. X plus 5, x minus 5. Magic number. Magic number. Number. Okay, I got the magic number down there. This should work on all these terms. So, cancels, cancels. What do I have? 2 times x minus 5. X minus 5 cancels out x minus 5 plus 1. I'm just going to write the 1 down. X plus 5 equals, cancels, cancels. Wonderful. That's what I want. 16. All right. Looks like no quadratics in this one either. So we're going to distribute 2x minus 10 plus x plus 5 equals 16. Combine the like terms. 3x. Remember, that's a 1. Minus 10 plus 5 minus 5 equals 16. 5 goes over to the other side. Write your sign. Minus, now plus. 3x equals 21. 5 by 3. X is 7. Check it. 7 plus 5, 12. 7 minus 5, 2. You just need to check those two. And then, if it works in there, you got it made. So, again, pretty easy to do, It looks a little different from the way the book did it. The way the book did it, to me, looks kind of crazy. I don't even understand what the heck they're talking about. Okay. So this is the fast way of doing it. Magic number, and that's what they eventually did, but it just made it look crazy, crazy difficult. Okay. We got one more here. Let's see if we can figure this out. It says, given that function of x equals x plus 6 over x, find all the values for x. Find all values of x for which function of x equals 5. Function of x equals 5. Well, what they're saying is that they want this answer, function of x equals 5. They want this problem to equal 5. That's what they're saying. This problem should equal function of x, and function of x is 5. So they want this problem. You can put the 5 first, or you can put it afterwards. That's what they're really saying, is they want this problem to equal 5. Right, like that. Let's put this in the parentheses. Let's put the 5 over 1. Let's look for the magic number. The magic number is 1x. Okay, x's cancel. 1, let's cancel out the x. 1 times x plus 6 is x plus 6. Equals, the 1's cancel, and I get a 5x. Okay, and again, you don't want to try to add these in your head and you say, oh, okay, 6x equals 6x, and it's equal to 1. Take your time and write it out. Bring this x to the other side. It's going to become minus, let's make that a 1x, minus 1x. So I have 6 equals not 6x, but 4x. Divide by 4, x is, and you could either divide 4 into using the calculator, 1.5, or you could just reduce this 3/2. So either answer would be okay, would be acceptable. So that's the whole idea behind these. It's kind of fun. They're not too hard to do. If you just kind of, they can be pretty simple. You're going to use the magic number, magic number, magic number, magic number, magic number. Sometimes you end up with a quadratic and you got to factor it. Don't think every time you get a quadratic, the answer won't check. That's not true. Okay. It can sometimes work. But most of the time, you just end up with a nice answer, like we did on this one. Kind of confusing a little bit on this one, the way it was worded. Just trying to make you think. All right. So I hope you enjoyed it. Get practicing.